Hello, Calc. This is the part that we didn't have time to do in class today, and we were talking about the function y equals 1 over x. And when we look at that, we saw the slash, and we remember that from last year. And now we were talking about limits. So far we've covered the limit of 1 over x as x approaches infinity. And when we did that, we were looking at what happens as x goes out toward infinity, and we noticed the y value shrinking closer and closer to 0. Then we looked at the limit as x approaches infinity of negative infinity of 1 over x. And as we went this way, we saw that the value, the actual graph again, was approaching 0. And then, this is where I left you, we had a conundrum where we asked for the limit as x approaches 0. It turns out as x approaches 0, see if that shows up. As x approaches 0, I'm sorry there's quite a bit of glare in this room, but I think you can see what's going on. The limit as x approaches 0 of 1 over x is, well, as we came in from this side, remember x is approaching 0, so I'm starting out here and I'm seeing what's happening to the y value. Notice it's getting bigger, 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 and the closer I get to 0, the bigger it gets. So when it comes in from the right, it is positive infinity. So we indicate coming in from the right with a little symbol above the 0 to the upper right hand side of the 0 as a superscript, and that is means coming as x approaches 0 from the right, and that is positive infinity. That limit does exist. What about from the left? Now I think I'll have to go above here. So the limit as x approaches 0 from the left, we write with a little negative sign. What is happening to the function as we come in closer and closer to 0? Well, as you see here, the value is quite high on the negative scale. Then it goes lower on the negative scale, lower, lower. Look, when it's close to 0, it's way down here. So you can see the limit as x approaches 0 from the left is negative infinity. So when that happens, when the limit from the left and the right are different, the limit as x approaches 0 of 1 over x, we say does not exist. Because the limit has to be the same from the left and the right for the limit at 0 to exist. We can say it exists from the left, one-sided limit. We can say it exists from the right, but when we say just 0, it goes up from one side, down on the other, so we said it does not exist. So let's take that knowledge and try some on this graph. Take a moment and sketch that graph. It's going to be a little tricky to sketch it, especially when it's all in glare. I could find another spot to sit this. Maybe it'd work better. Maybe there's less glare. And zoom in and straighten up. Try that. Alright, sketch, draw that, pause it and draw that. And we will go ahead and look at that graph. Alright, we're going to look at that graph at several spots, and one of them is, we're going to look at the limit. Does it show? Not much borderless space left in that view, about right here. The limit as x approaches, say, 0. And we'll say, we won't put a plus, well, we'll go ahead, we'll come from the right. and the graph is just f of x, we'll call it. So what's the limit when we come in from the right? Well, as we get closer and closer to 0, what is this graph getting closer and closer to? Is it not the value 3? So what happens when we come from the left? Well, as we march in, we see it getting higher, higher, and as we get closer and closer to 0, it also, from the left, it also approaches 3. So when the limit is the same from the left and the right, we say the limit as x approaches 0 of f of x is 3. So that is a fundamental concept of limits. So the limit from the left has to equal the limit from the right in order for the limit at a spot as x approaches a spot to exist. Alright, let's try this one. What's the limit as x approaches minus 7 f of x here? So we're going to get closer and closer to minus 7. And as we do, I'm not going to write it up piece by piece, but I'm going to do it piece by piece. So I come in from the right, look what the values are doing. I'm getting closer, 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 closer. It has a hole here, but it doesn't matter because I'm never going to reach minus 7 where the hole is. So the closer I get to minus 7, the closer I get to the value for this straight part, which is at minus 4. So from this side it was minus 4, and as I approach minus 7 from this side, the left of it, it also gets closer and closer to minus 4. Since it was the same from the left as from the right, we say that it is minus 4. So I'll give you a couple to do at home in your comp books, and we'll check those first off when you come in tomorrow. So let's do the limit as x approaches 5. So what I'm asking you to do is check it from the left and the right, and if it's the same, then you will have the limit. If not, it would not exist. How about the limit of as x approaches, say, 4 of f of x? So if you would do that one in your comp book as well. And we will do the limit as x approaches infinity of f of x, and the limit, does that show? If I write up here, the limit as x approaches negative infinity of f of x. So I'll give you 4 to do, and we'll talk about those in the morning. Alright, thank you. This is part 3, but you're supposed to watch it first. So, hope that worked out. See you tomorrow.